Hello and welcome to the third and final video of the FP3 chapter, Differentiation. On the screen, if you've got time, pause the video and write down the 6 results that we've had so far. Just to review, if you differentiate sinh, you get cosh. Differentiate cosh, you get back to sinh. If you differentiate tan, you get sec squared. For r sinh, it was 1 over the square root of x squared plus 1. R cosh, 1 over the square root of x squared minus 1. And for r tan, 1 over 1 minus x squared. And there were some limitations on these, depending on the domains. In this video then, we're going to finish off this chapter by looking at the inverse trigonometric functions. So we're putting hyperbolic functions to one side, we're going back to inverse trig. And same as before, there are 3 different results here that are on the formula booklet, but you might be asked to prove them, so I'm going to go through the example for arc sine, or inverse sine. And as I said in the previous video, I think this is in this chapter because of the similarities with what we did with the r sinh, and that is the starting point. We're going to use arc sine, or sine power minus 1, not really a power, but whichever way you like to write it. If you put that equal to y, and then you move the sign on the other side, you get x is equal to sine y. And we know how to differentiate this. I did implicit differentiation last time, so on this video I'm going to do differentiation with respect to y, just to show there are different methods. If you differentiate sine y with respect to y, you get cos y. And then to get dy by dx rather than dx by dy, you have to invert this. Like so. And then, same as before, we need to relate this thing that we get back to the thing in terms of x, so that we can get x back into this expression. And same as before, we're going to use an identity to do that. In this case, a sine squared y plus cos squared y is equal to 1. So cos y, very similar, is equal to 1 minus, instead of plus, minus sine squared y square root. And again, I'm not going to put a plus minus on that, which we'll talk about with reference to the graphs on the next page. So putting that in here, we've got 1 over 1 minus sine squared y square root. And remembering, we know what sine y is. The whole point of doing that is so that we can change that back into x's. 1 over square root of 1 minus x squared. dy by x. So this is the derivative of arc sine x. If you were to do the same with the cos and the tan, you'd get the following results. The arc sine, and as before, just a quick reference to the graphs here. They're not quite as complicated as the previous ones. If you were to graph arc sine, it looks, so if you excuse my graphing, something like this in a limited domain, because we have to limit sine in order to get arc sine. And from, I should put on here, the magnitude of x should be less than 1. And you can see why in the graph here, but the reason for drawing the graph is to show that all of the gradients along here are positive. So I only need the positive root. And because of the symmetry, my drawing here is going to be even worse. Try and get this vaguely symmetrical. The arc cosine, so you can see as you go along these, because of the symmetry, the magnitude of the gradient at any given x value is the same, but the sign is the opposite. So what we have for the arc cosine is the same expression, but this now is the negative root, and not the positive. So I hope that's clear, but I don't know why I've missed these off. Both of these should have magnitude of x less than 1, because we don't want a negative inside the square root here, and because the cutoff points of the graph. The third one, arctan, is not quite so difficult. 1 over 1 plus x squared. And there's no limitation on that. As with the other results then, these are on the formula sheet. And that is our 9 results. You need to be able to use them. As with the other ones, we're just adding to the list of functions that you know the derivatives for. You need to be able to also use these and apply the chain rule, product rule, quotient rule, etc. as usual. So a couple of quick examples. Well, the first one's quick, the second one is not so quick. If we want to differentiate arcsine x squared, now if it was me, I would find that a little bit ambiguous. That should be x squared in the bracket like that. So to do this, we're going to need to differentiate arcsine of x. We're going to need this result in white, but then we also need to apply the chain rule and multiply by the derivative of the thing inside the brackets. And if you're watching a video like this, you've probably done this many times before. So we've got 2x from the derivative of the x squared times by the derivative of the outside function, so that's 1 over the square root of 1 minus x squared, where x represents the thing in the argument, but in our case this is x squared and then squared. So it's x squared from the question, squared from the formula. So if I tidy that up, we've got 2x over the square root of 1 minus x to the power 4. Second example is a little bit more involved, but a very similar idea. Given that y is equal to the arctan of this, find the derivative. Well, we're going to do the same thing. We're going to use the derivative of arctan, substituting this in for x, but we are also going to need to multiply by the derivative of this, which is what makes this a little bit longer. So I'll start off in red. So we've got 1 over 1 plus x squared, where x is the thing inside the arctan, times by the derivative of the thing inside. Now I've written it like that because off the top of my head I don't know what that differentiates to. I'm going to pull that out. Let me do purple. I'm just going to pull that out and do that over here. So if we want to differentiate this, you could use the quotient rule. Personally, I prefer the product rule. And if we differentiate that, we have to leave this 1 minus x and differentiate this, pull the power down, so that's a minus 1 plus x minus 2, plus leave the second part, differentiate the first part. Well, if we differentiate 1 minus x, we get minus 1, so that's actually a minus. Minus 1 times, leave the second bracket, like so. That's still looking pretty horrible. I'm going to tidy that up. So we've got a minus 1 plus x over 1 plus x squared minus 1 over 1 plus x. Now, to put those together, I'm going to multiply top and bottom by 1 plus x and combine these fractions. So we've got minus 1 is minus 2 on top, and then x minus x is gone. And on the bottom we've got the common denominator. That's a little bit tidier. Okay, so the derivative of the thing inside arctan gives me this. So back into red, let me tidy this first bit up as well. If I multiply everything here by 1 plus x squared, then it'll come up on the top, it'll come up here, and it will go away here. 1 plus x squared over 1 plus x squared plus 1 minus x, and that is still squared, times by the derivative of this, which we've got in purple, minus 2 over 1 plus x squared. And that will cancel very nicely. That goes away. And that will equal minus 2. If I expand this out, we've got 1 plus 2x plus x squared plus 1 minus 2x plus x squared. And that will also cancel a little bit, which gives us minus 2 over 2 plus 2x, and the final little bit of cancelling to give me minus 1 over 1 plus x, sorry, that should be squared, which is a surprisingly nice result given how it looked when I got to about here. It's come down and cancelled quite nicely. So that is the derivative of this. And that should be enough now. You've got these results. You've had a few examples to practice this for yourself from exercise 3c for the inverse trig functions, and from the chapter 3 review exercise for the whole chapter if you've got the Pearson textbook. And maybe I'll see you in the next chapter.